So number 4, it's asking where's the vertex of y equals x squared. And also number 3, this is going to be a review from lesson 27. If you watch the video I made, I go over that problem. But in the essence of time, we're just going to look at number 4. So what is the vertex of the graph y equals x squared? So here's where we're going to use some graphing technology to kind of help us with connecting the equations to these graphs. So I'm going to go to my Desmos and I'm just going to put in x, and then shift 6 makes an exponent, x squared, and there's going to be our parabola. So every time we input a number, so 0, 0, when we input a 0, our output is a 0. If we input a 2, our output is going to be a 4. So it's just going to square whatever x value that we put in there. And I can't quite get it to go exactly to 4. The vertex is going to be this highest or lowest point right here. And our vertex for this one is going to be at the point 0, 0. So that first answer, actually number 4 in our warm-up, the vertex is going to be 0, 0 would be our vertex. Now that x squared is also called your parent function. So a parent function is just the most basic form of a function. So here we're looking at x squared functions, and that's the most basic form of a function. There's no numbers being added to it, so it's just the most plain parabola that we can see, and it starts with a vertex at 0, 0. Now let's head in to look at example 1. New concepts, a shift. A shift is a vertical or horizontal movement of a function. Today we are investigating the quadratic function. So we're going to look, how does the function shift around the graph when you start to add numbers to it? So in example 1, we're going to graph y equals the parentheses x plus 7 squared. We're going to determine the vertex and the equation of the axis of symmetry, and then explain in words how the graph shifted relative to the function y equals x squared. So heading into Desmos again, we've got our parent function. And just recall, our parent function has a vertex at 0, 0. Next, we're going to take a look at the function x plus 7, and then shift 6 to get into my exponent, x plus 7 squared. And we'll start to investigate, well, what's happening to that particular graph? Let me just kind of get this side by side here. All right, so exactly what's happening to that graph. So here's my original function. I'm at 0, 0. That's my parent function. And then when I put x plus 7 squared, who can tell me where did my graph move? So just give me like words. Did it go up, down, left, right? Where did my blue graph go? Who's got it? It's going left. So that's a pattern we can start to see when we start to put a x plus 7 in there. So plus 7 is going to shift it to the left. And if you did x plus 2, it shifts it to the left 2. X plus 7 is what we had. X plus 10, it's going to shift it to the left 10. So when we start to see that in the parentheses, x plus something, it's going to start to shift it to the left. Now we'll also practice just kind of making a little sketch of these. So we have our parent function, which is going to be 0, 0. 1, 1, and then 2, 4. So there's going to be our points of our parent function. And then there's a direct reflection. So just like we saw in lesson 27. So there's going to be my parent function. I'm going to graph in red. Then in blue, we graphed our new function with the x plus 7. That's going to shift the vertex over 7. And then we're still going to have the exact same picture, just shifted over 7 units to the left. So then there would be our new function with the x plus 7. Okay, so now we're going to look a little deeper at these two graphs here. So determine the vertex. So the vertex is going to be that lowest point. It would be the highest or lowest point on your graph. So my vertex, I'm just going to say V. So my vertex is going to be -7, 0. The axis of symmetry. Axis of symmetry is the line that splits your parabola directly in half. And that's going to always be exactly the same as your x-coordinate of your vertex, so my axis of symmetry is going to be x is equal to -7. And lastly, explain how it's shifted, and that was exactly what Morgan told us. It's just shifted to the left. We'll say to the left 7. So there's going to be my relationship compared to the parent function. That one is going to go to the left 7 units. Now, using that same pattern, we can think about what's going to happen to the graph if I would put x minus 7. So now just kind of using how patterns work, if I went +7 and went to the left, -7, it's going to go to the right. And if I put like a -5, -5 here, it's going to shift to the right 5. So now we can start to see when you're putting a number in the parentheses there, that x minus 5 shifts it 5 to the right, x minus 7 shifts it 7 to the right, x plus 7 shifts it 7 to the left. We can start to see that whatever number we're adding or subtracting in there starts to shift that graph, that parent function, left or right. So let's head down to problem 2. Now what we are starting to introduce is what's called the vertex form of a parabola. Here it is. Vertex form of a parabola is y equals a x minus h squared plus k. Okay. Then next, when you have an x minus h, that's going to shift you h units to the right. And I apologize, my handwriting is not the best. So whenever we see that x minus h in there, that tells us it's a shift h units to the right. X plus h shifts us h units to the left. So I'm just going to say the exact same thing there, except when I have x plus h, that's going to shift me h units to the left. The next thing we're going to look at is, what does that k value do? So that plus k, what does that do? Or if I had a minus k at the end, what does that do? All right, and then we'll continue to talk more about what the that h and k are doing there. So heading back to Desmos, we'll take a look at putting in this second function. So next I'm going to put in f of x equals x plus 2 and then minus 1. Now the x plus 2 is very similar to what we did in the first problem. Instead of shifting 7 to the left, I'm only shifting 2 to the left. But then we could also take a look at that minus 1. So looking at if my vertex was originally at 0, 0, minus 1, is anybody seeing where is that minus 1? What is it doing to my graph? It's going to be dropping it down 1. And the overall, the vertex here, the -2, that represents your h. I don't know why that disappears there, but this was -2, -1. And the y coordinate of your vertex is going to match up exactly to what this k is. So the h and k are going to be special names that we give to the x coordinate of the vertex and the y coordinate of the vertex. Now heading back to our notes. If we have a plus k, that's going to move me up k units. And if I have a minus k, that's going to move me down k units. And then lastly, your vertex is going to be whatever your h and k values are. And then your axis of symmetry is going to be x is equal to h. So in a nutshell, there's going to be kind of what we're practicing. We're going to be practicing that h and that k. So when you're seeing your x minus something, you'll see a shift to the right. X plus something, you'll see a shift to the left. If it's a plus k on the outside of your parentheses, that'll shift you up. And if it's a minus k, that'll shift you down. So looking at this one, I've got my x plus 2, which means I'm shifting to the left 2. And then minus 1 means I'm shifting down 1. There's going to be my vertex. And then I can graph out some additional points. there's going to be my parabola. So graphing that out, there's what we'll start to see. And it doesn't ask us, but our vertex would be -2, -1. And then our axis of symmetry is going to be x is equal to -2. Because that's going to be right where that graph splits right down the middle here. So that's what we're practicing in day 1. And I really encourage you to click on Desmos, try it. If you're having trouble with where the graph is moving, you can put that function right into Desmos and you can start to see that graph shifting. So what I would recommend is on your Desmos, you have your parent function just always there. There it is. And then you can put in any new function and you can start to see where that graph is moving to get to that new vertex. So just a nice technology piece that we can use here as we work on our parabolas. So that is going to finish up day 1. So now we are ready for our practice on delta math. We are at 7:46. So if you are ready to go and branch off on your own, you are free to do so. If you want to stick around, I'm going to go through delta math problems. So we'll head into our delta math assignment next. And looks like I need to open that up. So here's an example of a problem that we will see on delta math. So we've got our parent function set up right here. And then we've got our equation, our vertex form up here. And then we are going to look at where is our vertex and then how can we start to add in numbers to get us to move to that vertex. So right here, first I'm seeing that my vertex is at -4, 2. So I'm just going to write that over here. Vertex is at -4, 2, which means I'm going 4 left, and then I'm going 2 up. So 4 left means I'm going to have a +4, x +4, excuse me. And then I'm going to have a 2 up, I'm going to have a +2 on the outside of my parentheses. So heading back to the example, I'm going to hit +4 to move it 4 to the left. Once you do that, you'll see your graph move. And then I'll hit +2. Once you do that, you'll see your graph move, and then that should match up to the graph that we are looking at. So there we see it, x +4. Remember, that's going to be your shift 4 to the left. That's what this is telling us. And then this +2 is telling us that it's shifting up 2. And once we get to there, we'll hit submit. And then it should show us that we did it correctly. So there would be our result. And then it's just going to kind of walk through the exact same problem we just did. And there it is. So that's all I have for today. If you have any other questions, you can stick on the line. But there's kind of how our delta math practice is going to work. And we have 6 of those to practice. So you can kind of get used to that shifting left, right, up, down on your assignment today. And that's all I have for you. Thank you. You too, Morgan. Yep. And then if you email at 1:45, I should be available after school. Mm-hmm.